Hi, boys and girls. It's good to see you again. I miss you, sixth graders, and I hope you miss being in school with us, too. You know, we're going to talk about probability today. That's chapter 12 in your book. And I wish we were there to help you explain this, because parents and students, if you've been trying to learn probability by just reading the material in the book, I don't blame you if you've been having a hard time. I think that chapter is written for someone way above sixth grade level. So what I'm going to do today is try to simplify what you need to know about probability and make it fun so that next time you see the word probability, you won't cringe. Okay, it'll be something that you already kind of know about and really don't even realize it. Okay, first of all, I want you to make sure that the word probability is not confused with the word probably. Okay, I have a friend who says the Lions will probably win the Super Bowl this year because they've never won it before. Well, that's certainly a questionable statement. In fact, I'd probably say, what planet are you from? But the word probability is an educated guess. And I could tell my friend that I don't think they're going to win based on the probability of what they did in the previous year. What I mean by this is this. First of all, and you should probably put this on your card, probability is nothing more than the number of favorable outcomes over the total outcomes. And I'll explain what that means, okay? Let's take the Detroit Lions of last year. They had 3 wins, 12 losses, and 1 tie for a total of 16 games. That's the total outcomes, okay? So the wins would be a favorable outcome. I put that as my numerator over the 16 total outcomes. And then we know from the last chapter how to change a fraction to a decimal. In your calculator, type in 3 divided by 16, and this decimal would pop up, okay? Now we know how to change a decimal to a percent just by multiplying by 100 or moving the decimal 2 places to the right, which would give us 18.8%. That means based on last year's probability, the Detroit Lions are only going to be able to win maybe 18, if we round it, 19% of the time, which isn't a very high probability, is it? The bigger this fraction is, the higher probability for a favorable outcome. The lower the fraction is, well, you know what that means for the Lions. Now, by contrast to that, let's talk about the New England Patriots of last year. They had 12 wins, 4 losses, and no ties, a total again of 16 games. Let's put their favorable outcomes, 12, over the total games they played, total outcomes is 16. We'll reduce that to 3/4, and I bet you know now that 3/4 is really 0.75, which is 75%. Their probability is a lot higher of doing well in the coming year. Well, of course, that's changed a bit now because Tom Brady and Gronkowski just got traded to Tampa Bay. But what you can see here is the higher the fraction, the larger the fraction, the higher probability that that team will do better. I always like to show this to kids when they talk about probability. You know, Major League Baseball, you often hear a batter bats maybe 295, 350. You know where they're getting that number from? Watch. Let's say a baseball player came up to bat 100 times and only got a hit 33 of the times, okay? Let's change that to a decimal. It would come out to be 33 hundredths, or 33%. That baseball player only got a hit 33% of the times that he was up to bat. Doesn't seem like very much, does it? Well, when you see it on a stat, on a baseball program, you'll see that batter was batting 330. They don't put that little decimal there, but that's what this means. Guess what, boys and girls? That seems like not very good, but a 330 batting average is really considered good. In fact, Ty Cobb, his lifetime batting average over his lifetime was 366, and he is a great star. What that means is, if I subtract 33% from 100%, that means he fails to hit, this particular player, fails to hit a ball 67% of the time, and he still gets his $1 million salary. How do you like that? That's really what probability is used for, to give us an educated guess. Okay? Now, on the test you'll be having in about another week, there's some key things you should know. And the first thing is an independent event. You know, little dice, you've seen them before, like this. Get them in a lot of games. they have 6 sides to them, right? And each dot represents one of the sides. There's 1 on that side, 6 on that side, 4 on that side. If I want the probability, that's what that P stands for, of getting a 6 when I roll my dice, it would be 1 try out of 6. 1 chance out of 6 tries that it would take for me to get a 6. Now, I can change that to a decimal, 0.17 if you plug it in your calculator, which is 17% chance of getting a 6 if I roll that dice. Okay? Now, you can also get the probability of getting an even number on dice. You know that there's 2, 4, and 6. Those are 3 numbers that are even. So the favorable outcome would be 3 out of the 6 sides, reduces to 1/2. So if you're going to roll the dice, you'd have a 50% chance, right? A half is a 50% chance of getting an even roll or number on your roll. That's what we call an independent event. Both of those are independent of each other. Now, sometimes there's compound events. What if I have a dice and in my left hand, I roll the dice, and in my right hand, I spin the spinner. Notice the spinner has 2 A's and 2 B's. What you do is find the probability of each one and then multiply them together. So let's say we want to know what the probability of a 4 is. Well, again, because there's only one 4 on the dice, it's 1 over the 6 sides times the probability, let's say, of an A. Well, I notice there's 2 A's there, right? So that's a probability of 2 over 4, which I know reduces to 1/2. So 1/6 the probability of rolling a 4 times 1/2 the probability of spinning an A equals 1/12, or 8/100 or 8%. It would take you 1 out of 12 tries maybe before you would be able to get both a 4 and an A at the same time. Okay? Now there are dependent events sometimes. Okay? Let's look at these 11 cards I have, and I put different letters on them. Okay? Notice though I have an H here and an H here, so there's 2 H's in these 11 cards. If I want the probability of finding an H, if I just picked it out at random, picked out an H, it would be what? There's 2 H's, so it would be 2 possible favorable choices out of the total 11. And I plunked that in my calculator and I got 0.18. Okay, that's the probability, 2 out of 11, of getting an H out of all these 11 cards. But now, what if I picked an H and threw it out and didn't put it back in again? I've changed things. My next thing I'm going to do depends now on the first thing I did. What it did is it changed quite a bit. Now I only have 1 H. So if I wanted a probability of an H, I only have 1 this time in this pile of cards. And the number or total number of outcomes is only 10. Because remember, I threw that card out and I didn't put it back. So my probability of an H on the second try is 1/10 or 10%, or 10/100 or 10%. So when there were 11 cards, the probability of an H, because there's 2 of them, was a little higher than when we only had 10 cards. The probability was 0.10. You see how that second draw depended on what happened in the first draw. That's what we call dependent events. They're separate, different than independent events. Okay? Now, you hear the word outcome tossed out a lot, okay? Let's say we have a dice again, or a singular form of that is die, and we're going to roll the die, and then we're going to, at the same time, flip a coin. You know, there's a heads and a tails on a coin, okay? So you may see this sometimes. This is called a tree diagram. If I roll a 1, it could go with a T, or a tail, right? Or it could go with a head. If I roll a 2, it could go with a T or with a head. If I roll a 3, it could be with a tail or a head, and so forth. What you do to find out the total number of possible outcomes is take the 6 possibilities on the dice and multiply it by the 2 possibilities on your coin. 6 times 2 is 12. You can have 12 possible outcomes if you want to know how many outcomes you could get by rolling 1 dice and 1 coin. Okay? Now, I think we just answered this question. How many possible outcomes of rolling a die and flipping a coin at the same time? There would be 12. Now, if you're reading the book, you've probably come across this word and it probably, made you very confused. And that was the word permutation. A permutation is nothing more than arranging items in a particular order. Let me give you an example. Let's say I wanted to write a report on my favorite kind of music, and I have 4 kinds of music: pop, rock, Western, and classical, okay? But what should I talk about first? Should I have pop go first, then rock, Western, and classical in that order? Or maybe I should have classical go first, and Western, rock, and pop. Or what if rock goes first? I want to know the possible number of order, or the arrangement that I could possibly have. How many different kinds of ways could I talk about my 4 favorite kinds of music? That's when we use the factorial. You may see this. There are 4 items, and you see an exclamation point. All that means is say, take the number 4 times 3 times 2 times 1, multiply all those together, and you'll get the number of possible outcomes. 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. I could arrange my, if I'm writing a paper, a term paper about music, I could arrange them in 24 different ways. Sometimes we need to know that as well. Basically, these are the important things that you'll need for the quiz, or assessment, I should say, coming up in about another week. If you have any questions, please feel free to ask Mr. Cameron, and I'll be happy to address them. And if not, good luck on the quiz. Just make sure you take your time. Don't freak out when you hear the word probability. It's really not as hard as you think. That chapter 12 in your book goes way into further details that we really don't need to know at this grade level. Okay? If you do, you're doing great. Okay? So good luck on your test coming up in about another week. Enjoy the rest of this vacation. You know, we're still in the Easter season, although it doesn't feel like that. And we'll hopefully hear from you again soon. Bye-bye now.